All right, good morning. Welcome back to Calc 2. So today we're going to talk about numerical integration a little bit. The formulas are pretty straightforward, but the execution, if you've tried the homework so far, you'll see it's a little tedious to, that's generous. Okay, but it is a very practical type of a thing because for the most part, your problems that you're going to encounter in the real world, they're not going to have analytic solutions. They're not going to have analytic ways to solve them. What do I mean by that? By analytic, I mean like, can you say integrate like e to the negative x or something? So yeah, you'll just pop in e to the negative x, you'll get negative e to the negative x plus c, or you'll have from a to b. But there's a formula you're given. There's a, sorry, I'm not going to put my little thing on here. You're not going to see anything. Okay. So you get e to the negative x, integrate. Okay, we get negative e to the negative x. So by analytic, I mean that you're given a formula to start with. You can integrate that, whatever that's going to mean, and you're going to get a nice integral, nice formula for a value, and you're just going to plug things in. In reality, you're going to be running some kind of an experiment. You're going to get some kind of a curve this way. You're going to get some data points, and they're going to say, hey, we need the energy in the system, or we need the work done by this, or whatever. So we're going to integrate this, and you don't have, I mean, this is a function. It passes the vertical line test, but you can't integrate this. Okay, I mean, I guess you could maybe connect the dots this way. Okay, but that's probably not what you're going to do. You're probably going to go ahead and assume some kind of continuous piece here. So maybe you get something like this. But still, like, this is likely to be some kind of computer-generated formula, which means this might have one formula, this might have another one, etc. Okay, so we still got to integrate this. Best of luck. Okay, so we have a couple of ways to do this. Okay, one of them is called the Trapezoid Rule. And the other is called the Simpsons Rule. Okay, and what the trapezoid does, trapezoid rule, kind of does exactly what we drew with the blue line, in that we just connect the dots with a straight line. Okay, so if you have some kind of a function, what you're going to do is you're just going to draw, whatever interval it says. Okay, it's often delta x, right? The change in x's. Some books will call it h. I think your book calls it h. And all we do is we just draw a straight line here, and we just get this trapezoid underneath of it, and go ahead and just grab those areas. Okay. Clearly, the smaller the little delta x's, the better approximation you're going to have. Okay, so that's trapezoid rule. Simpsons rule, similar idea, but instead of connecting the dots with a straight line, what we're going to do is we're going to connect 3 dots, and we're going to approximate a parabola for it, because we can figure out the ideas of area below a parabola pretty well. So we'll have something here, and we'll have a different parabola. So the way this works is, we need 2 points to make a straight line, to make a line between the 2 points. Okay. For a parabola, it's a similar thing, but we need 3 points, and then we could approximate the parabola. Okay. So I'm going to pause this so I can pull up the video here without working around it. Okay. So we're going to pause recording. I'll be right back. Okay. Went through and pulled up the trapezoid rule from your book. You are not going to be memorizing this formula. Okay. I will gladly give you this formula. You don't need to memorize it. Okay. So the only thing you have to make sure that you do know is like this b over a over n business. Okay, so what we're doing is we're just taking our first number and our last number. Okay, so this will be our a, I think this will be our b. Okay, however many subdivisions we need here, that'll be our n. Okay, n is equal to the number of divisions, okay, the number of regions. So in this case, it would just be 3. We'll probably put one more in here to be 4. technically they don't have to be the same size, but for ease of computation, we make them the same size. Okay. So the way you figure this out, okay, is where b minus a over n. That's going to go b. That's just going to be this region, isn't it? Okay. So this is going to be our delta x. Okay. So if it was 0 to 4, and we wanted 4 regions, right? We'd have 4 over 4. We would have delta x equals 1. So this would be 1 or 0 rather, 2, 1, 2, 3, 4. Okay. If this comes out to some kind of a crazy fraction or something, we're just going to add that fraction. Okay. So this b minus a over n. The n is the number of divisions. B minus a is the total length of the curve we want to deal with. Okay. This will come out to be delta x or h. Okay. And this is just the step size we're taking from one point to the other point. Okay. So we're going to need to figure out, like, what is this y value? Okay, we'll call that y0, I guess. What is this y0? What is this y0, y value? And what is this y? Okay, so we're going to need all of that when we set this thing up. Okay, but that's what we use our delta x or our h is, the total length of the region divided by the number of little slices you want to cut this into. Okay, that's all this means. Okay, and again, some books will call it delta x, some books will call it h. I believe yours calls it h, so we'll deal with that. Okay, so the way we do trapezoids is we're going to need both of these values. But the next trapezoid, we're going to need this value and this value. So look here, there's 2 of them here, but there's only one of the first one. So that's really what you have to remember for this. Okay, but again, when I ask you this question on your quiz, I write this down. Okay, just the way you see it right here. Okay, so we're going to have a to b, f of x, dx. I'm sorry about that. Change this around here. Maybe that'll help. This is b minus a over n, okay, or h. And then we have 1/2, and this is f of the first thing plus 1 f of the second thing plus 1 f of the third thing, and so forth. Okay, until we get to the end. Okay, what are we doing here? Why is this? I don't know. F of x to the n. Oh, I wish I would stop doing that. All right, put it up here so I can get to the center of my little notepad thingy here. Okay. So, but that's what the formula we're going to use. This is called the trapezoid rule. And again, you're not memorizing this. I'm going to provide this to you. Next idea is called Simpsons Rule. Okay, so same kind of an integral dx. Okay. Now, this one does the parabolas, okay? And again, you'll notice, like, we take the first 3, then we take the second one, and so forth. So there's going to be different weights on each of these values here. Like, they're going to have different importances, different coefficients, okay? So I did used to go through this a long time ago, but students pretty much told me that they just give me the formula, we don't care. Okay, so we have that. Okay. It has a very distinct pattern to it, though. Okay, so this, we're going to separate this b minus a over 3, and we're going to separate that out a little bit. Okay, so what that's going to look like is we're going to have 1/3 b minus a over n, right? Because it's often that b minus a over n has a different symbol, mostly h or delta x. So if I fold this 1/3 back in, see what happens, b minus a over 3n. So everything is still nice and legal, but you don't have to, you know, when you see one that looks like h over 3, you're not going to have to worry about that. Okay, the h is this part, it's still correct. They just group them a little bit differently. Okay, and actually I will tend to do that. Like, this is my preferred way of writing it rather than b minus a over 3n. Okay, I'd rather figure out my b minus a over n and then multiply it by 1/3. Okay, so that's generally how we do that. Okay, and again, I'm looking these up too. Okay, so we have an f of x0, okay, plus 4 of x1s plus 2 of x2. Okay, double check to make sure that that's there. 4, 2, 4. So it's just going to have this pattern. 1, right? We start with 1, and then 4, 2, 4, 2, 4, 2, 4, 2, and then until you're done. Okay. So however long that takes, or however many little subdivisions you have. The thing you want to make sure you have, like dot dot dot, okay, is you want it's going to end on a 1, but before that there's got to be a 4 of x. Okay, there's going to be a 4 f of x and minus 1. So the second to last, penultimate, that's what the second to last means, is penultimate. Okay, the second to last one, okay, is going to be, this is not going to work out. The second to last one has to have a 4, the last one has to have an n. That means you're always going to have an even number of n's in order to do this. Okay, so it has to be divided by an even number of n's. And again, we keep all the n's equal for ease of computation. Okay, in the definition for integrals says you don't have to do that, but again, it's a lot easier to think about it that way. Okay, and that's how you're going to calculate an integral. Okay, Simpsons rule is generally more accurate than the trapezoid. Okay, so Simpsons a little better than trapezoid. Okay, they're just kind of taking you through the history, right? This is the first one we came up with, and then later on somebody said, "Hey, why don't we get a little bit better here?" And they came up with the second one. Okay, so that's what we're going to have. Let's see. One of the problems they're going to give you in your homework is they're going to give you multiple iterations of this to see how many iterations you need, how many little n's do you need in order to come up with a maximum amount of error that you're going to be allowed to have. Okay, so you're going to take this when we do it with textbook stuff. Okay, you're going to know what the actual value is. Okay, but when you go off and do experimental data and you're trying to figure that, you may not know, but you might want to pick an n, right, so that your error, your error is only going to be so large. Okay, so that's what this exercise is for. Okay, so that's where we are. All right, and again, you're not memorizing this. Okay, I'm writing this down for you when you need it. All right, and I'm going to write it down just the way you see it here. Okay, we're not trying to trick you. I'm not trying to make you struggle with this. It's a complicated formula. It's not that bad, but it is. It's not something that I would want to memorize. So it's one of those things where it's like, yeah, I'm looking this up when I need it. That's what you're going to do. Okay, so don't look at this and say, I'm going to have to do that. Yeah, but you're not. You're going to be able to read it off of the page. Okay. So that's what we have there. All right. So let's look at some homework. Okay. And fortunately, this one only has 7 problems. That's plenty. Okay. And then we'll just kind of work through it here. Okay. So let's see. Why don't we start with 2? Okay. We're in question 2. Perfect. So it says, use n to approximate the value of the integral with the following methods: trapezoid rule, Simpsons rule, and then C, we're going to find exact value. Okay, we're going to go from 0 to 4. Okay, and then it goes from 0 to 4, and we have n equals 4. Okay, so let's set this up and see what we've got. Because this is only 4, I think we could do it on a piece of paper here. Okay. We get the bigger numbers, you're going to need a spreadsheet. Okay, not just a calculator. You're going to need a spreadsheet to do this thing. Okay, so I just want you to know that on a quiz, I've kept it to kind of the first couple of few problems because they're smaller. Okay, so we have 9 over 5 minus x. Okay, so here we go. Oops, wrong one. What do I want? I want this. All right. So we have 9 over 5 minus x. Okay, dx here. You know, I did see some people with a little bit of problems. You could write this way instead. Okay. You could put the dx in the numerator, or you could leave it outside like times. Okay. Either way is just fine. Okay, so 0 to 4. Okay. So what if we just wanted to integrate this thing? We'll do part C first. Okay, so this is going to be let u is equal to 5 minus x, and du is equal to negative dx. Okay, so dx would equal negative du. Okay, so when I go to integrate 0 to 4, we'll say u and u here. Okay, so we have 9 dx is equal to negative du. Okay, and then we're going to divide by 5 minus, 5 minus u was just u, 5 minus x rather. All right, so we're going to say this is negative 9 u0 u4, and we're going to have du, well, 1 over u du. Okay, you can write it like this. I'm usually used to writing it this way, negative 9 u0 u4 u5 u4, and then 1 over u du. Just how I learned it. Okay, that's the rhythm I'm happy with. Doesn't matter which way though. Okay, so this is just negative 9 natural log u. Okay, from u0 to u4. Okay, so this is negative 9 natural log of 5 minus x. Okay, and we're going from 0 to 4. Okay, notice that when I put this in, both of these are going to be positive numbers. We don't need the absolute values anymore. So we have negative 9 natural log. Oops, don't need the absolute values. We can take those out. Okay, and we have 5, come on, draw, 5 minus x. Okay, from 0 to 4. One other little trick you can do is, notice there's a negative sign here. We can go ahead and put this inside with the limits. So this is 9 natural log 5 minus x. And what's going to happen is we're going to have a 4 to a 0. So I took the negative outside and I swapped these. Okay, so that might make computation a little bit easier for you. Might not, but that's what we're doing. Okay, so this is 9 natural log 5 minus 0. Okay, minus 9 natural log 5 minus 4. 5 minus 4 is 1. What is the natural log of 1? That would be 0. Okay, because what it's asking is e to what power equals 1. That's what we're doing. E to the 0 power equals 1. Okay, and we just have 9 ln 5 here equals, we're going to need a calculator now, but that's what we're doing. Okay, so we have 9 times the natural log of 5. And what do we get? We have 14.48, we'll say 14.485. Okay. We went to 3 decimals. Okay, let's double check. Round the answers to 3 decimals. Okay. What we're going to do is we're going to intermediate values to go to 4 decimal places. Okay. So, and then round to 3 decimal places for our answer. That's pretty common. Okay. So we would write the answer as 14.4849, I guess. And then our final answer this time, we'll round this guy up to a 5. So we have 3 decimal places, 14.485. Okay. There we go. Now, let's go ahead and use our trapezoid rule. Okay. So the first thing we have to do is like, okay, we are going from 0 to 4. Okay. And we are told that use n equals 4. So this is a nice version because we get a delta x equals 1. Okay, so b minus a over n, this is equal to, right, this is equal to 4 minus 0. And what did they say for n? We're going to consult that and say, well, we're going to say n is equal to 4. It's not always going to work out quite so nice. Okay, so maybe next example, I'll find one that is a little bit messier. In this case, n is equal to 4. This is not just because they match. Okay, this is because this is what we were told to do. 4 minus 0 is 4. 4 divided by 4 is 1. So this is b minus a over n is 1. This is also delta x. This is also h. Okay. So the next thing we're going to do is we're just going to say, okay, well, we're going to have a little table here that we're going to need. Okay. So here's our x's. Okay, we're going to have 0, 1, 2, 3, 4. Next thing we're going to need, okay, this is 9 over 5 minus x, right? This is 9 over 5 minus x. So remember, we haven't done anything here. I mean, we don't know what the integral is yet, okay, let alone a numerical value. Just have this function. This might be a chart, this might be a table, this might be a graph. You might have to look these numbers up rather than calculate them. But for us, we're going to say, okay, well, this is f of xi, f of x0, so 9 over, right? 9 over 5 minus 0, this is just 9/5, right? So this is going to be 9 over 5. Okay. When I plug in 1, right, this is 9 over 5 minus 1. So 5 minus 1 is 4, 9/4. Okay. Then we're going to have F2. We're going to have 9 over 5 minus 2. So that's going to be 9/3. We can abbreviate that to 3. Okay. So I probably should have been a little bit more conscious of my space. All right. Then we have 9 over 5 minus 3. 5 minus 3, so this is just going to be 9/2. Okay. And the last one is 9 over 5 minus 4, which is just going to be 9 over 1. We can abbreviate that to 9. All right. So that is our first little 2 table entries here. Okay. Now, and that might be all we need. I might rate a C for a coefficient here, where this is going to be 1/2, 1, 1, 1, and 1/2. When we get the Simpsons rule, this might be a little bit more important or a little bit more useful because you're going to be able to see like, oh, I'm supposed to multiply by these. Okay, I'm going to try to go up to Trapezoid Rule again, just to look this up. Notice the first one is a half, everybody else is 1, the last one's a half. Okay, so all I'm going to do is I'm just going to multiply this. Okay, so this is f of xi times my coefficient. Okay, you can call it times weights. Okay, weights would be the 1/2, the 1. Okay, so this is going to be 9/10. This is just going to be 9/4, 3, 9/2, and then this also is going to be half times 9, 9/2. Okay, these are the ones I'm going to add up. Okay, this one I'm going to add up. So what do we have for Simpsons rule here? For Simpsons rule trapezoid, we have b minus a over n. That was just 1, and now we're just going to add up the stuff in here. Okay, so we have b minus a, right? 4 minus 0 over 4, which is 1. And then what we're going to have here, okay, is going to be, we have 9/10, right? 1/2, so 9/10 plus 9/4 plus 3 plus 9/2 plus 9/2. Now, later on, we're going to get the Simpsons rule. I don't want to remember like 4-2, 4-2, because I know I'm going to mess that up. Okay, so we're just going to add this up here and we're going to see. All right, so let's see here. We have, let's go with 9 divided by 10, okay, plus 9 over 4, okay, plus 3, plus 9/2, plus another 9/2. All right, make sure we're looking good here. So I'm just, oh, I don't need that because I just added them. and we're going to add those up. We get 15.15. All right. So we kept all the decimals. Okay. We weren't going to, we didn't need to go out to 4 because at worst we have quarters. Okay. And then we have some halves. And that's it. That's our approximation for this integral. Okay. So the proper one, this was 14.485. And our approximation was 15.15. Okay. So trapezoid rule. We got there. We got 15.15. 15.15. Okay. And we'll check our answer. Great. We're doing well. Now let's try it with Simpsons Rule. Okay. So same idea. Okay. You could probably have worked a little bit neater than I did and have better stuff here. Actually, we can't do that. We can just pretty much going to copy and paste this. Okay. I'll have copy and paste with this idea though. So here's my x's. Here's my f of x's. These are going to be the same thing. The only thing that's going to be different now is my coefficients are going to be 1, 4, 2, 4, 1. Okay. So this column right here, coefficient, that's the only thing that's changing. And then we multiply, we're going to get a different value. So what do we have here? We had 9/5, 9/4, 3, 9/5, 9/4, 3. Okay. 9 halves and 9. And 9. And then we had 0, 1, 2, 3, 4. Okay. So here's my coefficients times my f of xi. Here, ci, I guess, or wi, because there a lot of people used to call them weights. Okay, because we're saying we're weighting how important each piece is. All right. So same idea here. We're just going to say, well, this is 9/5 times 1. You don't need a calculator for that. We have 9/5 or 9 times 1. Okay. And then we have 9/4 times 4. So that's just 9. 3 times 2 is 6. 9 halves times 4. So that's 9/2 times 2 times 2, because 4 is 2 times 2. Cancel. That's an 18. Okay. And we're just going to add these up. Okay. So what do we have here? We have 9/5. Okay. Plus 9. Plus 6. Okay. Plus 18. Plus 9. Okay. So we add those up. 40.8. Yeah, because we have a 1/5 here. So this is 40.8. Okay. And what was the first thing we had to multiply by? Right, we had to multiply by, going up here, sorry about this, b minus a over n times a third. So b minus a over n, right, this 4 minus 0 over 4, that was just 1. So we're just going to multiply this thing here, all the way down, keep going, by 1/3. So we need 1/3 times 40.8. Okay. So I'm just going to divide this by 3. All right. It up by 13.6. Okay. So here we end up with 13.6. Okay, double check myself here. All right, and we'll check. What did I mess up? 4, 2, 4, 2, 1, 4, 2, 4, 1. All right. 2 cancels, it should be 18. And then 1 at the end. All right. 9/5 plus 9 plus 6 plus 18. Plus 9. There it is. Okay. Sorry about that. It's 9/5 plus 9 plus 6 plus 18 plus 9. That'll be a difference. So it's 43.8. Okay, and again, times 1/3. Divide by 3 either way. Okay, so this is 48 divided by 3. 14.6, that looks a little bit better. 14.6. So we'll go here, we'll say 14.6. Okay, we'll check that one. Excellent. And then at the end, what did we have to do? The first one we did, the first part was all the way up here. And this was 14.485. 1.485. Okay. And we'll check this answer. Excellent. And that's what you're doing to get all this stuff done. Okay. Let me tell you how I'm grading this. I'm grading it, did you apply the formula correctly? Okay, there's a lot of arithmetic in here. And the way I grade, there's a lot of not pulling one grade down from you because you messed up an arithmetic part. Okay, that's also why it's important to show your steps so that I can see it's like, why did they get the right answer or wrong answer? That's why I can check and see, like, what did you do? Did you change a 6 into a 9? Not a big deal. But that's what we're doing here. Okay, so I only ask you one, by the way. I don't ask you to do trapezoid and Simpsons rule. I pick one. That way it's a little bit easier to deal with. All right. So let's go ahead and have a little question on 4. Okay. So this one, compare the results of the area found by the area of the circle. Okay, that's what we're going to do. So we're gonna, actually, you know what? I might make a part 2 out of this. I think that's what I'm going to do. I will see you in the next video.